Well, good morning, everybody, and thanks, Al, for that nice introduction. It's really good to be here. This is a very CDM-like looking audience, and I like that a lot. There's no doubt about it. I want to thank NASA. I want to thank Akbar and his associates, certainly Sean and Al and others for asking me to be here this morning. I was very excited and happy to be able to do this. He asked me what kind of presentation I was going to have and slides and so forth. Well, I'm not big into slides, so I brought my presentation with me here. But anyway, for me, the work that is being done, particularly the recent work under the air technology demonstration at Charlotte, has been a real CDM effort. I mean, we've been fortunate as American, as the lead carrier, to work with some really sharp people from NASA, from the FAA, from our local facility there, our local hub folks, and we can't forget the NATCA folks who have been all in on everything we've done down there, and we appreciate it very much. This is kind of, we're finally getting there after about 20 years, and I just thought I'd go through a little bit of history on this stuff that many of you will remember. But for me, this world of the surface, it dawned on me at some point years ago that it was sort of a black hole. That, you know, once we get the wheels in the well and we climb to cruise and we descend and we land, that portion is, we're pretty good with that. If we say it's going to take an hour and 13 minutes, pretty much it does. But getting to the runway and getting from the runway back to the gates and so forth has presented a problem for us. And my real interest started when I was with Northwest Airlines, and some of you may remember that way back when, 20 years ago actually, in Detroit, we managed in a snowstorm to strand about eight airplanes out on the tarmac for 6 to 8 hours each. We didn't know where they were. We kept getting reports of, yeah, well, they're being towed to the hangar now. This is happening, that's happening. But really what we found out after the fact was a lot of the stuff that we were told wasn't really happening. So we couldn't really get a tractor to an airplane because there was a snow berm in front of it. So after that occurred, there was a gentleman that was a COO at Northwest at the time. His name was Richard something or other. I can't remember his last name. Oh, Anderson, I think it was. And he called my boss and says, you know, why is it I know everything about my airplane from takeoff to touchdown, but you can't tell me a darn thing about it when it's on the surface of the airport. I want that fixed. And Richard was one of those guys, when he said, I want that fixed, he usually wanted something fixed. So we set out in Detroit looking for ways that we could better manage the airplanes on the surface. And I was over at the tower one day visiting with the ATM over there and the NATCA folks, and we were walking out through sort of the basement, and there was this PC there. And on this PC, I said, what is that? Because I saw targets on the ground with a data tag that said American, or it said Northwest, or it said Delta, or whatever. And I said, whatever that is, that's what we need as a start. And so we ended up entering into a three-way relationship, and this is where my relationships with NASA started. There was a gent at the time named Wayne Bryant with NASA, and they were doing a study in Detroit on dynamic runway occupancy. And there was a program called ATD-2, which I can't remember now, but it was identifying aircraft on the surface. And this was kind of the beta version of what they were doing. So we ended up in a three-way partnership with Northwest Airlines and NASA and the FAA and the contractor at the time. And we started using this display. And I don't remember what we paid per month, but it was so clear to us so quickly that we had no idea what we were doing. We shoved airplanes away from the gate and went, that's that. We would shove 5 airplanes out in a row going over a departure fix that had a 20-inch rail restriction on it and not know what we did. So we very quickly started to learn how to better manage ourselves away from the gates and kind of to the handoff point from the non-movement to the movement area. And that started us, and by the end of 1 year, we had already realized that, wow, we can do this a lot better. We thought we were really, really good at de-icing, for example, and we were awful because we were putting the wrong airplanes in sequence and so forth. And so the surveillance is what started everything. That's what it started. And I was interested as an ops guy. I want to know where my airplanes are. That's what I wanted to know. But I had some of these other guys in the room that were always saying, yeah, but look at the data we can get on the backside here. And I said, yeah, okay, that's really cool, but you know, I'm the ops guy. I just want to know where the airplanes are. But it ended up, we found out after about a year that the data on the backside was extremely valuable. And that's where we learned to sort of better manage ourselves in a very, very crude way, but better manage ourselves on the surface. And within a couple of years, we moved on and we deployed the first commercial, in the U.S., commercial Aerobond system in Detroit, and then we spread that to Minneapolis, and it went on from there. But that was, again, focused primarily on the surveillance, but we started learning on the backside of what the data could do. In that 2000 to 2005 period, a lot of other things happened, of course. We had the Safe Flight Initiative. We had Memphis, where MLAT went in at Memphis and working with FedEx and so forth. And again, NASA very much involved in that. Then we moved on in about 2005 or 2006, the Surface Management Work Group of CDM got underway. That sort of morphed itself a bit over the next 3 or 4 years, and after the FAA's Task Force 5 on Next Gen in 2009, it morphed again into the Surface CDM team. Same ideas, trying to find a concept of operations where we could operate more efficiently on the surface. And out of that task force also came a recommendation that the FAA establish a surface office that was focused purely on doing surface work and then working with the Surface CDM team to develop a ConOps. And so I retired from Delta at the end of 2011, went to work for the FAA. I have to say Nancy Kalinowski was one of the FAA people at the time that sort of got that, and she said, hey, can you come and help us do this? Well, of course, I loved it, and I knew that there was a lot of potential there. And it wasn't the next-gen potential, it was just the fact that we should be able to better manage ourselves from the gate and into the airspace. So I was there for about 3.5 years. During that period of time, the SCDM ConOps was developed. A lot of you were on that Surface CDM team and with others that helped develop that concept of operations. And that was connected up to the TFDM program, which you guys are all familiar with now, and we're going to all get more familiar with it over the next 2 to 3 years. So all along through that process, there were people that were sort of champions. And NASA was very much involved. They were doing work at Dallas. They were doing work in other places. And in about 2013, a guy named Ed Bolton, who came to the FAA from the Air Force and ran the Next Gen office for a few years, he recognized the value of this. And I think with General Bolton and Charles Bolden, Bolton and Bolden, they got together and looked at ways that they could push forward. The FAA had no money at the time. I know that's a shock, but they had very little money. And they were looking for a way to push this idea forward. So while at the same time the TFDM program was finally getting some legs within the FAA, we needed more real-world exercising and real-world research to get this to come out the backside. So the FAA TFDM program and Surface CDM ConOps were married. The reason was TFDM was a heavy program, cost a lot of money, but didn't really have a really good benefits case. Surface CDM was light, it was an efficiency program, it was about process and technology and using that to better manage the surface. So it had benefits, but it had no money. So they put them together, and out of that we've got what is the TFDM program, and is starting to roll out at an airport near you. In the meantime, we as American down in Charlotte went through the ATD-2 concept and started working with NASA again, NASA, FAA, NATCA, all the folks in Charlotte. But it all came back to the kind of the same thing, if I can get this slide to advance, which it won't, but I guess we don't need to have it advance. Oh, there it goes. Good. Okay, so this, I want to go back, take a step back. This really is where it started in terms of bringing everything together through the Surface CDM team and then moving on to the work with TFDM and then to NASA. And this we kind of called the pagoda. I'm not sure exactly why. This was the first iteration. You can see the date on there, 2012. And the idea was to say, how do we build this? And so if you follow the pagoda from the bottom up, the base, the foundation is data. And I want to make clear, I heard from somebody the other day that it's all about the data. It's all about the data. And a guy that I thought was a pretty bright guy said, no, it's not. It's not about the data. The data is a component. It's about the people. It's about the processes we build. And it's about how technology uses the data. But really what it's about is execution. He said it's about performance. It's not about the data. It's about what we do with these things. But still, obviously, data was the foundation. The next thing was we needed some sort of basic surveillance of the airport, and then we had to build up from there. And at the top of this thing, but back in 2012, we said we've got to have procedures, roles, responsibilities. We all have to understand what we're doing in this new world. So this slide is, as I said, everything started in 2000. This slide took until 2012 to be developed, but in my view, we kind of built off of that. Okay, I think you saw this one yesterday. I think Carol Hugel was up here in the morning early and had this slide. We took this is a few years ago when I was at the FAA, we took that typical display you see where the airplane takes off, climbs, cruises, descends, lands, and looking at that, we thought, you know what, the problem really isn't in that in that cruise or climb, yeah, we got things we can do that'll be more efficient. Let's turn it upside down, because the bottleneck is on the airport surface. It's really that turnaround period of time. So we tried to focus on that, and that's where we went forward from that point, and kept that in mind the whole time. So this slide, to me, sort of puts it all into a nutshell as to what we need to do in terms of being more efficient. And we talk a lot about things like, time savings is critically important. We talk about fuel savings, but fuel savings these days, we've got to start thinking about the environmental benefits of what we do here. Because in the industry we're in, that's becoming more and more important every day. So again, it's not about the data, it's about what we do with it, the processes that we build, how we train people to use it, and so forth. I have no doubt that we are going to succeed. I also have no doubt that the transition might be more difficult than we think. I think it's important for all of us in this room to remember, especially all of those that are operators in the industry, that this is something we asked for. Certainly I can speak to that exactly, because 20 years ago I said, I got to be able to see these airplanes and do something better on the surface. It's a black hole. And many of you, I think, have joined in that. And the nice thing through this period of time is it hasn't just been airlines. I mean, we've had everybody in the room. So we've had airlines, we've had business aviation, we've had general aviation, we've had the FAA, we've had NATCA, we've had NASA, and we've been a team. But I will tell you, I'm so happy to be here, because the partnership with NASA in Charlotte is just amazing. It's been fantastic. The level of cooperation and collaboration, whether you're talking to our ramp controllers in our control center there, or you're talking to the ATM over at the tower, or you're talking to the NATCA rep, or you're talking to the NASA team themselves, everybody has gotten together and they are jazzed about what we're doing there. And, we are now taking it, when we first started this, we were just looking at giving it time to move off a gate to get to the movement area, TMAT time, which you're all familiar with. But really, in Charlotte, we expanded that to get into that overhead stream. And I had some doubts about it, to be honest. But it is doing amazing things. And I guess it was about a month and a half ago, Dan Elwell was down in Charlotte for a tour. And he was blown away. And I remember we were walking him to the gate when he was leaving, and he said, that is the highest level of collaboration I have ever seen. And nobody had to pick up a phone. So what you guys have all pulled together to do, and certainly with the support of our NASA partners, which is a huge piece of all this, we are going to get this done. And it's going to make a difference to all of us. Most important, it's going to make a difference to the traveling public and keep us out on the leading edge. We can build boxes all day long, and they can do some amazing things, but it's about the people and the input and the processes that they develop that'll make a difference. So I'm really happy to be here today. I won't take any more of your time. I love this stuff, and obviously I'm still around. I love this stuff. But this is the future. And we've got work ahead. The work is not going to end when we roll out the first TFDM at some airport somewhere. We've got more work to do with the FAA. We've got more work to do with our partners at NASA. We've got more work to do with our NATCA partners. And I think working together, we're going to get this thing done, and you're getting it done. So thanks very much. I appreciate being here today.